Welcome to Ask and Learn.
So in this problem, we have a refrigerator with a coefficient of performance of 2.25. It operates on 135 watts, so that's the rate of power going into the mechanical or electrical energy going into the refrigerator. The contents inside the refrigerator at 5 degrees Celsius. And then we put 12 1 liter containers of water in there. So that means we have 12 liters of water, which is 12 kilograms. And they're initially at 31 degrees C. And we want to figure out how long it takes to get them down to 5 degrees Celsius. So we have the relationship of the coefficient of performance is the rate of heat transfer divided by the rate of power, or the rate of work, the mechanical electrical power. So we have the rate of heat transfer, and this would be the rate of heat transfer coming out of the water, is 304 watts. Now, to get the time, we need to figure out what total heat needs to come out of the water to get it from 31 degrees Celsius to 5 degrees Celsius. And so I use a constant heat capacity, which is an approximation but pretty accurate. And so we know the heat needing to come out of the water then is the mass times the heat capacity times the change in temperature of the water. The mass is 12 kilograms. The heat capacity is very large here, so as 4,190, and that is kilojoules per kilogram Kelvin. And then again, the change in temperature is 26 Kelvin, or 26 degrees C. Whenever we have a change in temperature, we don't really need to do the conversion to Kelvin because that's just a constant offset. So when we take the difference, we can convert these to Kelvin and then take the difference and we'll get 26 also. So then we plug everything in and we get that we need to take out 1.31 megajoules of heat from this water. So quite a bit of heat. And if we assume that there's a constant rate of heat being transferred out, we can get the time it takes by taking the amount of heat transfer divided by the rate of heat transfer. And that winds up being 4,300 seconds, or about 1.2 hours. So it takes quite a while to get all this water down to the temperature of the surrounding refrigerator. Again, because the water has a fairly high heat capacity.